So we're going to look at the trig ratios related to a particular angle. In this case, we're given a triangle that we have to work with, and then we'll actually look at all of the things you're going to be discussing in this chapter, so sine, cos and tan, and then their reciprocals, so sec, cosec and cot. So the first thing we're going to do here is read the question. So it says, in a triangle ABC, the angle ABC equals 90 degrees and the angle CAB equals x degrees. Now you really need to know that with angles, when they write three letters, and in this case the three letters are the vertices, the middle letter is where the angle would be. So if we think about this as being ABC, B is going to be the 90-degree angle, so that would be B. So you could think about this as being A, B and C up there. So B is 90 degrees. Now this one here says CAB, so we would start at C, go to A, and then go to B. So you're drawing a little triangle, and that's what is represented by this part here. So that's the angle CAB, and because A is in the middle, that tells us that this is our angle, which is x degrees. So we've got that from the question. We know AB equals 6 centimetres. Now AB is the side length between A and B, so that's this side length here, so that's 6 centimetres. And BC, which is between B and C, is 5 centimetres. And we need to find the following. First of all, we need to find AC. Now we know this is a right-angled triangle, so we're going to use the classic Pythagoras theorem, which tells us that if we have a triangle which has a right-angled triangle which has A, B and C as the sides, A squared plus B squared equals C squared. That's your Pythagoras theorem. So we're going to use that here with the numbers that we have. Just use blue. So we've got 6 centimetres squared plus 5 centimetres squared equals, and let's just call this unknown side here y, because we already have an x, equals y squared. So what you're going to want to do there is use your calculator or however you want to do it, and we actually end up with here, we're going to have 36 plus 25 equals y squared. So therefore, I'm just going to turn this around. Y equals, normally it would be plus or minus the square root of what you have when you do square roots as well. We'll talk about that in a second. I better do this first, 61. Now we're going to take the square root of each side. Now it would normally be plus minus square root here, but because we know we're dealing with positive values, because it's a length of a triangle, we're just going to use the positive square root. Okay, so positive square root of 61, and remember that it's centimetres. So that's our answer to the first part, part A. All right, cool. So once we've done that, what we want to do now is have a look at the trigonometric ratios. Now the ratios that you're going to want to think about here are all of the basic ones, sine, cos, tan, and then because this chapter is about reciprocals so far, those ones as well. So first one, sine of x equals, remember sine opposite over hypotenuse, SOHCAHTOA. That's really handy to remember. It tells you about the trig ratios. So remember that sine opposite over hypotenuse. So in this case, opposite is 5 over the hypotenuse, which we know now, we can actually put that into our picture as square root of 61. Square root of 61 can't be simplified any further, so that's it for sine x. The next one, cos x, adjacent over hypotenuse. So adjacent is 6 over root 61, and there's nothing else you can do with that as well. Tan, same thing, opposite over adjacent. In this case, the opposite, which is 5, over the adjacent, which is the angle that's next door. So 5 over 6. Now the other three that we're interested in are the reciprocals. So one on sine of x. Now remember that this is the one that you don't think it's going to be. It's cosec. So always have a look at that third letter. That will be the same letter as what's underneath there. So cosec of x equals. Now because we know what sine x is, this is actually 1 over the top of this answer here. It's a reciprocal of this, which basically means it's flipped. So all we have to do is actually take our original answer here and flip it over. And that's it. Easy as. So because it's flipped here, Okay, we flip this as our answer. And so again here with cos, we're going to have sec x, which is 1 over cos x. Remember to look for that third letter there. So 1 over cos x. And we know what cos x is, so again, 1 over cos x, it's just flipped. Okay, same with the last one. This is 1 over tan x, which starts with a t, so that means the third letter is a t. It's cot x. Cot x, and again, it's going to be flipped over. So you're taking information from a question, building your triangle, putting in the information that you know, using Pythagoras' theorem to solve for a side that you don't know, and then to find your trigonometric ratios, you're just using your SOHCAHTOA. And then for your reciprocals, which are these guys, remember that reciprocals are 1 over, and the key reciprocals are cosec, sec, and cot. And then it's a matter of just flipping over what you already know.